Hey there, my people. Welcome back to Z-Wink University. In the last episode, we talked about insecure direct object references, or IDORs, and how easy they are to find. But what we didn't talk about was how to sort of dig into more complex IDORs, like objects that have random letters and uppercase and lowercase and numbers. And so how do you get one of those, right? Like, it's obvious if an IDOR is, 1, 2, 3, 4, 5, 6, you can change it to a 5 or 4 or a 3 and get somebody else's info. But what happens if it looks like, that or something, and you want to know if you can get to somebody else's information? That's what we're going to talk about today. And I'm going to show you one way to do it. There's more than one way, believe it or not. But I'm going to show you one way to do it using the Burp Suite Intruder tool. The first thing I want to do is find an interesting target for us to play on. And I want to do something live on the internet here. We're not doing anything malicious. We're just sort of playing. What I want to do, I think, is use bit.ly, like a URL shortener, because I think those work kind of perfectly for what it is we're trying to do. And I've actually found a lot of bugs using URL shorteners with this technique, so I think that makes sense. So I'm going to type in, let's just do site:bit.ly, and let's try like bit.ly like that and see if we can get a link to come up for a URL shortener. Okay, let's maybe take off the site bit.ly. That might be not what we want. Sweet, there's one. All right, do note, Google indexed this, not my fault. Okay, so we're going to request this in the URL right here. I don't know what it is. It's just a bit.ly shortcut. We're gonna hit enter, and it's a documate thing. Great, we don't care. All right, close that out. Now what we're gonna do is come back over to Burp Professional. And I already have this scoped to bit.ly, right? Thought about that ahead of time, saved you 30 seconds, you're welcome. And what we're gonna do is see if something like this might be an IDOR, and it is, of course. I don't think bit.ly links are considered secure, so it's okay for us to guess these, right? What you would do is, if in the wild you were signed into a site and you saw an object, that looks like this, and it could be in a path. Let's send this to the repeater just so you understand what we're doing here. Let's say it was in a path like API user, okay? And this was a user object, or API/profile, and this was a profile object. See, now it seems more important because you would be able to pull somebody else's profile information or something back if you could guess it. Whatever, it's not, it's a bit.ly link. We're playing, it's the same thing. What you do, take the URL, right click on it, and say send to intruder, or you can hit Control-I, send to intruder. You will see this thing turn orange, indicating you have sent it to the intruder. All right, when you first pull up the Burp Intruder, it's going to have these little, what look like $ but aren't $ symbols in front of things. These are what tell the intruder where you want to insert your payloads for attacking. The whole purpose behind Intruder is basically to send large quantities of crap in differing types and styles and ways to a server for you, thereby sort of making a bot where you don't have to go to Python and program your own web bot and that sort of stuff. It does what it says it does. You're trying to brute force into something. You're trying to intrude into something. I don't want to do a full lesson. Hit clear, by the way. Clears all those things out when you first load the payload. I don't want to go into a full lesson on Burp Intruder right now, but I do want to make this specific to IDORs. Now, we may have all dropped out of school or not paid attention in math or whatever, but there's this thing called entropy or complexity or permutations or whatever you want to call it, of how many potential combinations there could be here. What do we see? We see that there's numbers. We can assume the numbers are 0 through 9. We see uppercase letters. We can assume the uppercase letters are A through Z based on the letters we see here. We see a lowercase letter. We can assume that there's lowercase letters A through Z, and we see the number 1. Based on just having one instance of this, though, we don't know if they follow this exact format where it's like number, uppercase, 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 lower number, or if it's completely randomized throughout. So all we have to do to prove that an IDOR exists is try to get somebody else's information back as easily as possible. What I would do here to start with is probably a cluster bomb attack, okay? And these are pretty simple. A cluster bomb attack, you just select from right here, lets you identify multiple payloads. And in this case, we want to just specify the last 2 characters, I would think, to start with. Smallest number, you know, necessary. Let's just add, so click, you highlight just the number 1 and click this add $sign that's not a $sign symbol. And then you click the lowercase I, click the add $sign that's not a $sign symbol again, and you should have 2 payloads defined, okay? In a cluster bomb attack now, you would go over to the payloads tab. And what this is going to do is we're going to iterate over some list of integers or letters or whatever for these 2 characters, leaving these the same. All right, the assumption being that maybe this is static, or maybe we will randomly collide with another, you know, another ID. Okay, so we're going to go over to payloads now, and you see there's a payload set. So we've got 2 payload sets, one for each of the defined parameters that we added. So payload set 1, what we want to do is come down to brute forcer, and there's a lot of fun options in here. Brute forcer is what we need for this. And see how there's a minimum length of 4? Why would we need that to be a 1, right? Because it's 1 character. It's 1 character. And these are the potential letters that could be or characters that could be inserted into that one parameter spacing. Okay, so again, just to iterate, let's say this is the I right here. Okay, the lowercase I. We're basically telling it to send 36 payloads, lowercase a through z, numbers 0 through 9 right there. All right. And because this one was a lowercase, let's just do lowercase letters on it. Maybe it follows a format. See the payload count's decreased to 26 now. Now we're going to select payload 2. Do the same thing, go down to brute forcer, change the length to 1 and the max length to 1. And now it's going to be the number of payloads in character 1 times the number of payloads in character 2 for your total number of requests. Because what it's saying is for each of A through Z in payload set 1, do each of the payloads in payload set 2. So you try every possible combination, okay? This one had a number, so let's just try numbers in this one, which will make the request count very low. This is just 260 requests. It's almost nothing. Okay, so that's all we needed to do here. Then you go over to the resource pool. It's possible and very likely, because this is bit.ly, that we're going to get throttled and or blocked by a WAF or something if we try to go too fast. Whenever you're starting with something like this, you might want to do the following. Well, let me back up. The resource pool, what this means is how many simultaneous requests you're sending from your computer to the server, okay? And the server itself will have a hard limit of what it can actually process and respond, especially depending on the overhead of the request server side. So like if I send, you know, to some dinky web server out there that doesn't have but like 1 CPU running the server and is already overloaded with like antivirus software, you know, if I send it 100 requests a second, it's probably going to blow up, and we might inadvertently create a denial of service. Not saying this is how you create a denial of service attack, but it is. But I'm not saying that. So in customer resource pool, a custom resource pool here, I'm going to create one that says custom resource pool 1, maximum concurrent request 1, okay? And this is like baby slow mode to start with, just so you can see how the requests are working. And then I'm going to hit start attack. And we're not going to run this attack to completion doing 1 a second. That'll take longer than I feel like waiting. Oh, that actually worked. That's so sad. Okay, so I think we will just leave it at 1. That was unexpected. So when you're doing this, that's really funny. I'm kind of impressed. Good thing we used bit.ly. We're done. I'm just going to go ahead and stop this attack if I can figure out how to do that. Results, positions, payloads, resource options. I'm missing my... Oh, it's covered up with my recorder. All right, we'll just let it go. I can't actually see the button. Normally, I would stop the attack by clicking on a button I can't get to right now. So let's let that finish. Good, it finished. Under status, sort this thing by status, okay? A 301 redirect for bit.ly means you found something. Because ordinarily, that's bit.ly's function, right? So what we're saying here on this request is that the combination 2btxy lowercase c0 found a match and responded with a 301 move permanently header. And as you can see, this forwards to a website with an uploader and an integer. If we come down here even further, let's go just a random payload y and 1. This is somebody's Google Drive document. If we go down to a t and a 3, this is bigspacer.com. Obviously, bit.ly links are not secure, as we've just seen, because out of, how many payloads did we send there? Out of 260 payloads, we were able to get, how many matched here? We were able to get 258 to match. I don't know, no, that's not working. I can't sort that like that. Oh, bear with me, people. Computers are hard. Hey, Burp Suite add-on request. Please tell us how many records we have selected when we select them. Okay, somebody from Portsmouth will eventually watch this. Anyway, that would be cool right now if it was like Excel and it told me how many records I had selected. Doesn't really matter. And if you were interested in these records, you could just hit Control-C right now, and you could come on over to Notepad and paste all those values out and then do stuff and things with them. And these are ones that were just the 301 response code. So, and that's tab delimited or whatever, so that would import into Excel nicely, which is cool. So that is the intruder, the cluster bomb attack in a nutshell. I mean, it's not any harder than that. I wish I could make this look more complicated for you. Now, the difference between like the sniper and the cluster bomb, right? Sniper I use all the blasted time, and sniper is for defining a single payload. So if I just wanted to, just really quickly just try like just that number, for instance. You could do the sniper, you do the same thing, brute forcer. We could just do this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we just have 36 payloads. We could set the default pool to 10, so it goes a little faster this time. And start, bloop, I'm done. So that was cool. And out of those, you can see all the matches we've got. Why did we get a 302? What's up with that? I don't know. That actually set a bit cookie. Okay, they all set a bit cookie. I don't know. Maybe it's one that used to be there, it's not in there. Anyway, when is the 302? Why is it different? Oh, I got a bitly warning on that one. Okay, cool. Anyway, so yeah, this worked, and I think that sums up stuff and things. And I hope hackers don't use this for ill purposes. Remember, this is just an example. Don't go out there and start scraping people's bitly link and doing nefarious things with them. I mean, this is just to show you what you can do with the intruder. And sometimes you'll see these tokens sent out to you via like text message or something. As a shortcut password reset link or something. Anytime you see these, they look complex, just remember, think to yourself in your head, are these really complex enough, right? It's probable that somebody else has been out there. So quick math lesson, okay? Quick math lesson if you need to be able to do, an example here. Let's say that we had, let's just say that we had A through Z, right? So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I did it. All right, so that's position 1. This is position 2. And let's say you had a token that was 3 numbers, 1, 2, 3, and 3 letters, X, Y, Z. All right, this just makes the math simple. All right. So how many possible combinations is this, right? Well, we've got 10 possible numbers. So that's 10 times 10 times 10. Some math genius is going to come and watch this video and tell me I did this wrong, but whatever. And then we've got A through Z, which I think is 26 letters, but I went to a school in the South, so it's hard to say for sure. 26 times 26 times 26. Okay, so that should be our total amount of payloads. So if we do 10 times 10 times 10, all right, that's only 1,000 payloads times 26, 26,000 times 26, 676,000. Okay, that's getting to be a decent number of payloads, right? But remember, you can normally leave like 1 character or 2 characters the same, but let's just go ahead and do the next one anyway, and then times 26. Total of 17 million possible, 17.5 million possible combinations there. So while it may look secure, or even if they mix it up, if they did like this, it's suddenly in a Z. That suddenly looks a lot more secure, doesn't it? Because they alternated the letters and the numbers, but it's not really. I don't think that's much different than Bitly. It's just that they use uppercase 2, which greatly increases the complexity. But then again, a couple billion people or whatever use Bitly, so the chances of colliding with an ID are much greater. So when you're on a target, think about the size of the target you're on. Like if it's a company that has, like millions of customers and there's only 17 million possible combinations in this token, yeah, that's going to be a problem. Okay, it's obviously going to be a problem. So just start crawling it until you find something. And again, when you're testing things like this, it's better to have a second account on your own if possible, and just automatically try to get to the object knowing its value. But sometimes you can't make a second account. Like literally it's not possible because the program doesn't let you or the application doesn't let you. So you have to do what you have to do. But do be careful with IDORs if it's a post or put or patch or delete or anything invasive that's not just pulling data back. Error with great caution, up to and including not doing it at all, okay, if you're not sure what's going to happen, because you don't want to mess with somebody else's data without permission. Don't cross that line. We're white hat, we're ethical people, okay? I'm just showing you how to use the tools. You know, with great power comes great responsibility, Spider-Man, yada yada stuff. Make sure that you know, you're doing the right thing, okay? Continue to send me messages on Twitter or whatever if y'all want to see custom stuff like this. I want to make sure that everybody's understanding things, and I'm happy to make these little ad hoc videos all the time. Thanks for tuning in. Stay tuned for more from the Web Academy. Hit subscribe, and I'll send you one of these amazing hats, possibly, if you win. I'll have to make a raffle, but it'll be amazing. Bye, guys. Thanks.